Welcome to this particular module, and here actually this is our next class. So, next lecture in fact, and in this lecture we will have two modules, and both the modules will focus on op amps. Alright. So, now we have seen how you can design an integrated circuit, right, which is the example of a MOSFET, and the same technology is used for designing the circuit as well. So, once you know the process to fabricate the MOSFET, you will know the process for fabricating rest of the devices. Alright. So, we started with basics and introduction of monolithic ICs, if you remember in the first class. Then we moved on to how to make the op amp, how to make the MOSFET, and then we have also seen some characteristics of a enhancement type, depletion type MOSFET, right. We have solved one or two problems for the MOSFET. Now, let us see what are the operational amplifiers, right, and I have prepared a set of experiments for you guys, which I will show as a part of this particular course. So, you know how we can actually use this operational amplifier. Okay. So, today let us see how we can use the operational amplifier. First of all, we should understand how the operational amplifier works and what are the characteristics of the operational amplifier. So, when you talk about operational amplifier, like we have discussed earlier also, it is used to perform several operations, right. It is used to perform summing, there is summer, it can be used to perform integrator, it can be used to perform differentiator, right. It is also amplifier if you use proper feedback, it can be made oscillator if you use another kind of feedback. So, we will see several applications of op amp as well. Okay. So, to start with, let us see what is op amp and what are its characteristics, right. And if you remember, we have seen this IC earlier also, right. So, now you know that how this chip or what is there within the silicon chip, and if there are a lot of transistors, at least you know how you can fabricate one transistor, that is your MOSFET. So, when you fabricate one transistor, you can fabricate millions of transistors in the same process, right. Whether you are fabricating one MOSFET or you are fabricating 10 MOSFETs, the process remains the same, right, process remains the same. Now, when you talk about operational amplifier, you should know a little bit history of operational amplifier, how it was emerged and how it was invented, and now what we are using or what kind of op amps we are using. Alright. So, we have already discussed this particular point. So, we are not going into detail about this, but if you see the brief history of operational amplifiers, the first patent for vacuum tube op amp was in 1946. In this the op amp was made out of vacuum tube, okay, vacuum tube, because all the functions earlier, if you see the transistors, if you see the other electronic components, earlier vacuum tube technology was used, and slowly with the advancement of technology we came to the present technology, which is our IC. So, in the next one was first commercial op amp, which was available in 1953. So, the first patent was in 1946. The first commercial op amp, it looked like this, you see here, and it was available in 1953. This was the first commercial op amp, how it looked like. Okay. Now, if we move to further, then discrete IC based op amps. In 1961, you see discrete IC, you can see here some resistors, you can see other components, you can see here some transistors, right. So, discrete IC based op amps was first invented in 1961. Okay. So, we started from 1946, we reached to 1961. Now, first commercially monolithic op amp, first commercially successful monolithic op amp was found in 1965. Okay. This was the first time when monolithic ICs or monolithic operation amplifier was available commercially, and it was successful. Then in 1967, we got the first op amp which looked like this, which currently also we are using the same operation amplifier mu A 741 by Fairchild. So, leading to advancement of the technology which is integrated technology, we could have this particular IC. Okay. So, the point is that we started from 1946, we reached to 1967, but still we are using the same operational amplifier, you see guys, from 1967 to present, alright. So, this field is vast. You can first you should understand what is within the operational amplifier. Once you understand, you can make a better operational amplifier as well. There is a lot of scope of performing research in the area of electronics, in the area of semiconductor devices, in the area of biomedical devices, and all this area more or less will require the knowledge of analog circuits, will require the knowledge of op amps, will require the knowledge of ICs, and that is why this course becomes kind of basic or the base that needs to be extremely strong to understand further several devices, to understand several other devices, alright. So, that is why I have molded this particular course in a fashion that anyone and everyone who has a basic understanding of semiconductor electronics or just basic electronics can opt for this course and can understand how the electronic things or particularly op amps, particularly MOSFETs and ICs work. Again you see that lot of things I told you that I do not want to go into depth of this particular topic. The reason is that we have to take all the students together and come to a point that we can advance further, So, there can be another course where it can be advancement of this particular course. Okay. So, anyway, coming back to the screen, what we see is that we have this IC. Now, once we have this IC, what is there within this IC? What is there within the operational amplifier? So, when you take an integrated circuit, when you take an operational amplifier, what you see? You see that there are 5 terminals, 5 main terminals what you will be using. We say inverting terminal, we say non-inverting terminal, we say positive supply, we say negative supply, we say output. Now, there is 2 more terminal 1 and 5 that is used for offset, and then there is terminal 8 which is not connected, right. So, we have 8 terminal IC, where we talk about single op amp, when we talk about 741 mu A 741, right. So, when we talk about the op amp and we talk about the terminals, then first thing that we have to understand is, you see we have to apply 7 and 4 plus V minus V. These are called bias voltages, alright. And there is an advantage of this voltage that we will see at some point, or I can give you an example that this operational amplifier has several characteristics like infinite input gain, and how this infinite input gain, what is the maximum output voltage that you can obtain even if the op amp has infinite input gain. What is the maximum output you get at the output of the operational amplifier? We will see. Okay. Right now, just understand that it has 5 terminals. For positive supply, it has negative supply, it has output terminal, inverting and non-inverting terminal. Easy, very easy, right. Now, input at the inverting terminal results in opposite polarity. That means, if I apply a input in this particular fashion, right, my output here will be opposite polarity. Polarity is opposite, right. If this is 0 degree, this you can see is 180 degree out of phase. If this is 0 degree, this is 180 degree out of phase, right. So, this is the anti-phase output. When we apply input to terminal number 2. When the input at non-inverting terminal, if I apply input at non-inverting terminal. So, now what I will do? I will apply input here, then my output will be in phase, you see, same polarity, alright. Then the op-amp is fabricated. So, now we understand, right, that if I apply input at inverting, output will be out of phase. If I apply signal at non-inverting, output will be in phase. Then what is another thing? The op-amp is fabricated on a tiny silicon chip, we have seen that, right, and this op-amp has billions of MOSFETs, billions of transistors, alright, and how to fabricate the transistor? We have seen how to fabricate a MOSFET, isn't it? We have seen how to fabricate a MOSFET, actually the process flow, not actual fabrication, but at least we know now how. If somebody asks you, can you understand what is this process flow, you can say yes I can, and because I know how MOSFET is fabricated, I know how we can have billions of MOSFET on one silicon chip, on a tiny piece of silicon chip, right. So, now we see that op-amp is fabricated on a tiny silicon chip and packaged in a suitable case. Fine gauge wires are used to connect the chip to the external leads. We have seen this in the previous slide. Now, let us see some interesting advantage of op-amp, okay, over transistors. First is, op-amp is a very high gain amplifier fabricated on a integrated circuit. This is a high gain amplifier, okay. It has combination of transistors, FETs, resistor in a pinhead size. So, that means that when you take a small silicon chip, it has lot of circuits that can include transistors, resistors, FETs, right, and so on and so forth. And it has extremely high gain, okay. So, two things we understood about op-amp: it has extremely high gain and it has lot of components. Then what are the applications of op-amps? What are the application of operational amplifier? It can be used as an audio amplifier, it can be used as a signal generator, it can be used as a signal filter, it can be used as a biomedical instrumentation, and numerous other applications, okay. We will see how it can be used as a signal generator, filters we can design using op-amp, and we will take an example also, So, having said that, what are the advantages of op-amp? Why we have to use op-amp over transistor amplifier, right? We have seen transistor based amplifier, CE amplifier, CC amplifier, CB amplifier, right? Why I have to use op-amp? Right? These are just few examples. There are a lot of transistor amplifiers. So, the advantage of op-amp is, first is low power consumption, then cost is less. So, when you get a IC, it will be like 15 rupees, 15 Indian rupees, right. So, it is really cheap, very cheap, low cost, right. Then the IC is so small, right. If you have IC, then what you will see is it is very small, tiny, and that is why it is more compact, reliable, it is more reliable, right. Finally, higher gain can be obtained and design is extremely simple. Why? Because if I have op-amp, if I want to make inverting amplifier, I have to just put 2 resistors and that is it. If I want to make 2 non-inverting amplifier, again 2 resistors and that is it. Integrator, differentiator, 1 capacitor, 1 resistor, and that will be it, right. Oscillators L, C or R in a particular formation, particular combination, I can get oscillators. So, designing of analog circuit becomes extremely easy when we use op-amp over transistor based amplifiers, alright, easy, very easy, right. So, now let us see. So, now you got it, right, that we have very high gain, we have lot of components, there are a lot of application of operational amplifier, and there are several advantages of operational amplifier over transistor amplifiers, transistor amplifier, correct. So, let us go to the next characteristics. Next characteristics, what is that? Sorry. Okay. Ideal operational amplifiers, we are talking about now ideal situation. Okay. And then we will see that in truth or practically what is the case. So, these are very important points. If you remember these points, these are repeated in several parts when we talk about the operational amplifiers. Okay. First point is it has infinite voltage gain, it has infinite voltage gain, and the voltage difference in the input is magnified infinitely. That means that if I apply, so does that mean that what does that mean? Infinite voltage gain means, suppose I have a op amp, and I have inverting terminal, non-inverting terminal, right. Suppose inverting terminal I am grounding, non-inverting terminal I am applying a signal which is, let us say 1 volt peak to peak, 1 volt peak to peak. Okay. And it has how much? Infinite voltage gain. That means at the output, can I generate a voltage which is 100 volts peak to peak, because it has infinite, right. So, I have infinite voltage gain, that means that I can have infinite amount of voltage, I can get 1 million times output, can I have this much voltage, right. So, what we will see is that the output, this output, even it is infinite voltage gain, the output cannot exceed more than the supply voltage, What is supply voltage? Your plus VCC, your minus VCC. So, even your input is small, let us say 1 volt, the maximum output that I can get is, you see, 5 volts, minus 5 volts, a little bit less than that, you will see in the experiments also. Okay. That means you can use op amp as an amplifier, and it has an infinite voltage gain, but that voltage gain also is governed by the supply voltage or the bias voltage that we apply across the op amp, operational amplifier. It is very important to understand infinite voltage gain. Okay. But in truth, that is in experimental op amps, in practical op amps, you will see that the gain is very high, is about this much value, around this much value. Okay. Okay. Next one is infinite input impedance, So, no current flows into op amps, right, because if the impedance is very high, then the current cannot flow, right. Suppose I talk about resistance, the resistance is extremely high, can current flow? It will not flow, right. Same way, if the excuse me, if the impedance is extremely high, can current flow? Current cannot flow into the inputs, input of the operation amplifier. Now, in experimental op amps or in practical op amps, what we will see that the input impedance is about 10 to the power 12 ohms, right, for FET based op amps, Now, the point is, okay, it has infinite input impedance, but why it has infinite input impedance? Because at the input of the operational amplifier, we are using the FETs, MOSFETs, right. MOSFET and FETs has extremely high input impedance, that we know, right. So, also you have to see that what is the first stage of the op amp and what is the last stage of the op amp. So, when we understand what is there in the first stage of op amp, you will also see that the amplifier that is designed in the first stage of op amp has extremely high input impedance, and amplifier which is at the last stage of the op amp has extremely low input impedance, alright. So, that is why when we see about input impedance of the op amp, it is infinite or it is extremely high. When we talk about output impedance, it is 0 or it is low, it is low. Okay. Last is infinitely fast, it is very fast, it has infinite bandwidth. This is when we talk about ideal operation amplifier, but practically it is limited to few megahertz. Practically it is limited to few megahertz, and it can also be determined by understanding the slew rate. By understanding the slew rate, that means if I apply the signal at the input, can I also see the corresponding change in the output simultaneously, right? It has some lag. So, what is that lag? How fast my op-amp output can track the input, right? So, that will be by slew rate. I will show you the slew rate also later on. So, the point is that we have slew rate which is 0.5 to 20 volts per microsecond. We have limited few megahertz range, that is your bandwidth, that is your bandwidth. However, ideal operation amplifier, it is infinitely fast. Ideal operation amplifier is infinitely fast. So, what we understand from here? What we understand from here, that we understood 4 main characteristics of an ideal operation amplifier: infinite voltage gain, infinite input impedance, 0 output impedance, infinitely fast, right. But in case of actual op amp, in case of practical op amp, what we understand is the voltage difference is very high, the input is magnified at a very high range, but not infinite. Input impedance is extremely high, but not infinite. Output impedance is close to 0, but not 0. It is not infinitely fast, but it is extremely fast, and it has it is limited to few megahertz range, right. These are the cases of practical op amps, right. The top one are, the first one, the one that I am taking here, these are all the characteristics of a ideal operational amplifier. Ideal operational amplifier, easy, very easy, right. Now, whenever you use operation amplifier, you have to understand golden rules. What are these golden rules? There are 2 golden rules. Okay, golden rules. There are 2 golden rules. When op amp is configured in any negative feedback arrangement, it will obey the following 2 rules. So, now you see this sentence very clearly. What is written? When op amp is configured in any negative feedback arrangement. So, this golden rule stands true when you have negative feedback, when you have negative feedback. So, what are these following rules? So, first rule is that the inputs to the op amp draw no current, draw or source no current, right, draw or drain no current. That means, the input to the operation amplifier, here the current is 0, is 0, and this is true whether feedback is there or not, does not matter. This is true even the feedback is not there. Okay. First golden rule, inputs to the op amp would draw no current. Second, the op amp will do whatever it can to make the voltage difference, between these two. So, voltage difference between the 2 inverting and non inverting terminal, or between the input terminals, to be 0, to be 0. Okay. So, op amp will do whatever it can to make the voltage difference, that is V 1 minus V 2, to be 0. 2 golden rules, understood. First is the current, input current inside the op amp is, there is no current, because it cannot draw any current, input to the op amp draws no current. Second is that the voltage difference, right. So, the voltage difference between the 2 inputs would be 0, This op amp would do whatever it can to make the input voltage difference or voltage difference between the input terminals to be 0. These are 2 golden rules that we have to remember when we understand the operational amplifier. So, if I go to the next slide, what I will see? I will see that I have to compare the ideal op amp versus real op amp. So, if you can focus back on the slide, what we see? We see that the parameters are written, ideal op amp is there, and real op amp is there or practical op amp is there. You see here, that is what we were discussing, right. Differential voltage gain or voltage gain infinite. Second is bandwidth product, gain bandwidth product infinite, input resistance infinite, output resistance 0, right. This is what we have seen. But when we talk about real op amp or we talk about practical op amp, then we see that it is not infinite, it is extremely high. It is not infinite, it is extremely high. It is not infinite, it is extremely high. It is not 0, it is low or close to 0. It is low or close to 0, right. So, this is the ideal versus real op amp. Now, if you see the equivalent circuit, very easy to draw equivalent circuit. You see, this is AOL into VID, okay. D came here, so forget about that. This is your open loop gain input the differential input voltage VI1 minus VI2. Now, you see there is no connection, because infinite input impedance, right. So, if you apply voltage VI1, VI2, we can write like this, then you have a gain, infinite gain AOL, open loop gain VID, right, and the output, you see output is connected directly. So, there is a 0 resistance, right. You have to see this ideal op amp, it has 0 impedance, 0 resistance, you can see here, it has in differential voltage gain infinite, right. You have to see here input resistance infinite, you can see here, right. But in case of actual op amp, what it will be, same circuit, but here we can put a resistance, because now we have some value of resistor, it is very high, but still it is there. So, we have used a resistor at the between the input terminals. Then we have very high gain, you see the resistor is about 10⁶ to 10⁻12 ohms, it has very high gain 10⁵ to 10⁹, right, very high gain, that is fine. Then it has low resistance, low output resistance. So, still there is a resistance, it is not 0, right. So, you cannot connect like what we have seen in the ideal op amp, we have to put a resistor, we have to insert a resistor, right. That is what we have done, we have inserted a resistor and this resistor value is low. Okay. Finally, we are showing the output voltage, here also we have shown the output voltage. So, this is how we can draw the equivalent circuit of the operational amplifier. This is how you can draw the equivalent circuit of ideal versus actual or real or practical op amp, right, ideal or real or practical op amp, easy, right. Now, let us see power supply. So, you have seen, right, that if I apply plus 15 volts and minus 15 volts to the op amp at 7 and 4, right, then it will be my balanced power supply, balanced, because both are same, plus 15 minus 15. But in some cases we will we also apply plus 15 volts and minus 12 volts, plus 15 volts and minus 12 volts, that will be my unbalanced power supply, Okay. So, op amp works on a dual power supply, but sometimes we will also see that one terminal can be grounded like this and only one terminal we are applying some voltage. But anyway, point is, in general op amp works on dual power supply. The dual power supply is plus minus 9, plus minus 12, plus minus 15, plus minus 22. Okay. These are the dual power supply and I have kept it red deliberately, so that you can understand that most of the time you will see that we are applying plus minus 15 volts, Okay. Now, the output is taken between the output terminal and ground is called single ended output. So, if the output is taken like this, which we already know like this, right, then it is your single ended output, between the output terminal and the ground, then it is single ended output. But sometimes we take the output from 7 and from 4, from 7 and 4. Okay. That is called double ended output, that is called double ended output. So, what is that? The output taken between two terminals and not with respect to the ground is called double ended output, balanced output, as none of the terminals is grounded, it is also called floating output. You see here in this particular case, single ended output, one terminal is ground with respect to the second terminal, right. So, it is also called it is not floating, it is not floating, but in this particular case you are taking the output from here and see here, that is between pin 7 and 4, but none of the pin is grounded, and that is why this is also called floating output. Okay. It is also called double ended output. Okay. So, this is the what we are understanding about the op amp's power supply and op amp outputs, how they are taken, either they are taken single ended or they are taken double ended, either we are applying balanced power supply or we are applying unbalanced power supply. Okay. So, if I go to the next section, that will be the feedback in op amps. So, what I will do is let us finish this particular module at this particular slide, which we understood now that what is op amp, right, what are the golden rules of the op amp, what are the characteristics of op amp, and what are the power supply, whether it is unbalanced or balanced power supply, right, same way single ended or double ended output. Now, in the next module what we will see is the further we will further understand the operation amplifier. Till then what you do is you again see this slides, these are very easy, very basic slides, and I will see you in the next module. I will see you in the next module where we will understand the op amps further, that what they consist of and what are the other parameters of the operation amplifier. All right. Till then you take care, I will see you next module. Bye.